All right. So there are 4 boxes today, and we're going to get right to the first box over here. Okay? The first box are the laws of exponents. Can everybody see that? Is this dark enough for you on the screen? Yeah, okay, good. Laws of exponents. And I'm going to give you numbers 1 through 4. Okay, and then we'll break it up, okay? So here is the first one for you, okay? Number 1. If you take any real number and you raise it to an exponent of 0, what do you think you get? I'll give you 3 choices. You either get 0, 1, or A. Which one do you think it's going to be? 1. Yes, anything to the 0 power has a value of 1. That is the first law. Is that easy, medium, or hard? That was easy. Good. Okay, we'll move on to number 2. Here's number 2. Okay. If I take A and I raise it to a negative exponent, so the base is A, the exponent is negative n. Does anyone have any idea, remember what you're supposed to do to get yourself out of this? Yes?
It'd be 1 over A.
Say again?
1 over A.
1 over A to the what? 1 over A to the positive n power. Yes. What is this called, everybody? There's a word for this. It starts with an R. The reciprocal, right? You take the reciprocal. Okay, I'll abbreviate that. We take the reciprocal, right? Good. There's the second law. Here's the third law for you. Okay. If I have A and I raise it to a power of m, and I multiply that same A and raise it to a power of n. So I am multiplying the 2 bases, right? I have a base A and I have a base A. If those are the same, and only if those are the same, what do I do to the exponents? Yeah, do you remember? You add them together. You're 100% right. Nice job. So that is going to be A to the m plus n. You add them together. Okay, so far so good? Okay, let's do number 4. Number 4 says this. If I have A divided by B all raised to the m power, the m is the exponent. Notice that the m is touching the parentheses first. Therefore, everything inside those parentheses needs to be raised to the power of m. So we get A to the m divided by B to the m. Let's move on to the second box then. I look crazy. Okay. Here we go. Okay, we're going to practice simplifying these. So let's simplify. The expression. What does the word expression mean? What does the word expression mean? What's the difference between an expression in mathematics and an equation in mathematics? Yeah. Yeah, an equation has an equal sign. So if this thing had an equal sign, we wouldn't call it an expression, we'd call it an equation, right? So there should not be any equal signs that we can see in this, right? So I have a few of these for you, right? Let's do number 1. 1A. We're going to go 3 squared. B, we're going to do negative 3 all squared. And C, we're going to do, oops, that's not what I want to do. We're going to do negative 3 all squared like that. Now, these look similar, don't they? Right? And some of these are the same and some of these aren't. Okay, so let's start with A. So the first one. 3 squared. What does the 2 actually mean up in the exponent? Yeah, Jonah? Yeah, this actually just means 3 times 3, which of course is 9. No big deal. Okay? 3 times 3 is 9. Okay, let's take a look at B here. What does this say? I have negative 3 all squared, but there's parentheses around that. How do you take care of that situation? What does that actually mean? Yeah, it means negative 3 times a negative 3, right? And negative 3 times negative. What's a negative times a negative? It's a positive, right? So this also has a value of 9, just like the other one did, right? Okay, cool. What about the last one, though? Is the last one different than the first 2? Yes, what do you think?
You'd multiply negative 3 by positive 3.
You multiply negative 3 by positive 3. What do you think in the back? Yeah, this is the opposite, right, of 3 times 3, right? So what is 3 times 3? 9. So this is negative, the opposite of 9. So that's a little bit different than it was before, right? Okay, so the first two are equal, but the last one is not. Okay, what do you think about that? Not too bad? Okay, cool. Let's do number 2. Here's number 2. And I have A. A is going to say 5 to the 0 times 4 to the negative 2. And B is going to say 6 to the negative 2 plus 1/6 all squared. Okay, let's work on the first one here. Number 2A. Well, 5 to the 0. If I go back up here in my notes, right, laws of exponents, right? Anything to the 0 power is what? 1. So I know exactly what to do with that one, right? So this is going to be 1, right? Multiplied by, now I have a number raised to a negative exponent. What should we do with that? Take the, what's it called? Take the reciprocal, right? Very good. So this is 1 over 4 squared. Okay, good. Now, 1 times anything is just anything, right? So what's 1 over 4 squared? How much is that? 1 over, how much is 4 squared? 16. Very good. There you go. Awesome. All right, let's do B. I have 6 to the negative 2 power. What do? I take the reciprocal. Very good. So I'm going to have 1 over 6 to the positive 2. Plus, now I'm raising a fraction to an exponent. According to the rule number 4, a fraction raised to an exponent, each of those has to get raised to that same exponent. So that should be what? 1 over 6 squared, right? 1 squared and over 6 squared. Well, that's just 1 over 36 plus 1 over 36. Now, don't forget how to add fractions. How much is 1 over 36 plus 1 over 36? 2 over 36. Does that simplify to something? You got it, right? That's equal to 1 over 18. Awesome. Okay.
Running out of room.
Turn it over on the back. Laws of exponents. And this is going to be numbers 5 through 6. Okay, here is number 5. Number 5 says, if you take two bases, a times b, and you raise it to a power of n. Okay? A times b all to the power of n. Well, that means that everything inside those parentheses is also raised to that power of n. So this has to be a to the n times b to the n. Number 6, one of my favorite ones. If I take a to the m, but then I take all of that and I raise that to the power of n. So I'm raising a power to a power on this one, right? What? Does anybody remember what you do? Yeah, and sometimes I like to do is I like to circle those to remind myself that you have to multiply the m and the n together. So that gives me this, a to the m times n. And the very last one, number 7. If you take a to the m divided by a to the n, if I am dividing two bases with different exponents, how do I treat the exponents? What do you think? Yes? You subtract them. Yes, very good. Awesome. We know a lot about this. A to the m minus n. And that is the equivalent of 1 over a to the n minus m. The book gives you that one as well, so I'm going to throw it in there. Okay? So that is also super important. All right. So we have all 7 laws of the exponents. Are there any example or anything you need from 5, 6, or 7 that can help explain before we start practicing with them? Going once, going twice. Feeling pretty good? All right, great. Here we go. Last box. Let's do some examples. Whoa. Okay. I'm going to have a A. A is going to be this. We're going to have 3 squared, all raised to the power of 2, divided by 2 to the third, all to the power of 2. All right, I see 2 things that we can do here, right? What's the first thing that we can do? Yeah, you can raise a power to a power, right? When you have a power to a power right there, what do you do with those? You multiply them, right? Okay, good. So that means that we're going to have this. We're going to have 3 to the, what's 2 times 2? 3 to the 4th. Good, great. We can do the same exact thing on the bottom, right? Right, we can multiply those 2 together. So what's 3 times 3? So this is 2 to the 6th, right? Okay, good. How much is 3 to the 4th? 3 times 3 is 9 times 3 is 27 times 3 is 81. 81. 2 times 2 is times 2 times 2 times 2 times 2. Next 2, 4. There you go. And that's the answer for that one. That was not too bad. Yep.
Why didn't you do... Oh, never mind.
Because they're different bases. Yeah, I knew that question. Any other questions? That's a good question. Someone had that same question earlier. Okay, let's do B. Let's do 2/3 all to the negative 3. Okay, what's wrong with this? What's wrong with this? There's a negative exponent, right? You're not supposed to have negative exponents in there. People get real upset when you do. So how do we deal with this? Take the reciprocal. Absolutely right. And what is the reciprocal of this? Yeah, the reciprocal of this is 3/2 to the what? To the positive 3. Very good. The reciprocal is 3/2 to the positive 3. Now, if I'm taking a fraction and I'm raising it to an exponent, then that means each of my pieces in my fraction, my numerator and my denominator, have to be raised to that power. So how much is 3 to the third? 27. And how much is 2 to the third? 8. And that's your answer. Nice job. You guys are doing great so far. Okay, and see, this is going to be a U-try. You're doing this one on your own. I'm going to give you this example here. I'm going to do x to the negative 2 times y to the third, all divided by x times y to the fourth. I'd like you to try that one on your own. All right. So first thing we do is notice that I am dividing my x's, right? So that means I'm going to have x to the negative 2 minus 1. Where does that come from? Where do I have negative 2 minus 1 from? Why is that there? Because I subtract what? I subtract the bottom one from the top, the exponents, right? Good. Now, what do I do with the y's? I have 3 and I have 4 right there, so that's going to be 3 minus 4, right? Who got this far? Put your hand if you got this far. Good. Okay, if you did not get this far, do you see what I'm doing? Yeah? Good. Okay, so how much is negative 2 minus 1? Yeah, so this is x to the negative third, and this is y to the negative 1, because 3 minus 4 is negative 1. But am I allowed to keep it that way? No, I am not allowed to keep it that way. I need to take the reciprocal of each one. So this is 1 over x to the third times 1 over y to the first, but we always write that as 1 over x to the third y. And that's what I'm looking for.